Okay, we're going to do a quick tutorial on the difference between covalent bonds and hydrogen bonds. So I'm going to begin with just a very general difference between them. Covalent bonds are strong bonds between atoms due to sharing a pair of electrons. In contrast, hydrogen bonds are a weak attraction between molecules. One set of bonds makes molecules, another set of bonds brings molecules close together. We're going to focus on covalent bonding between hydrogen, oxygen, nitrogen, and carbon. And if you've done your reading, you know that most of your body consists of these four elements. And these four elements are responsible for making biological molecules like DNA, proteins, nucleic acids, which are DNA, lipids, and carbohydrates. So learning about how molecules bond together will help you understand the structure of the core molecules that make up living systems. So let's just start with the simplest molecule that I can show you in terms of a covalent bond. The element hydrogen has one electron on its valence shell, as you learned about already. And that valence shell holds a maximum of 2 electrons. And because of that, hydrogen does not exist alone unless it is in a bond. So we have a vacancy in that outer orbital that needs to be filled. So what will occur is one hydrogen, or what can occur is one hydrogen can interact with another hydrogen. And the way they interact is by sharing their electrons. So from the perspective of this hydrogen, it has 2 electrons. The other hydrogen has the perception of having 2 electrons. And as a result, those electrons are being shared. So we represent this H2 as H bonded to H. This is a covalent bond, and it is strong. Let's do one more example, show you how methane works. Methane has the formula CH4. What this means is that one carbon is covalently bonded to 4 hydrogens. So when we look at carbon, carbon has an atomic number of 6, where 2 electrons will fill its inner shell. The inner shell is satisfied or happy, but there are 4 electrons left. Those 4 electrons will be in the second orbital. represented here by the 4 dots. That second orbital holds a max of 8 electrons. The end result is that there are 4 vacancies. Each of those vacancies is a potential for forming a covalent bond with another element that has an electron to share. And in this case, we're going to use hydrogen again, which has 1 electron on its outer orbital. That outer orbital holds a maximum of 2. So the end result is the carbon will share its electron with hydrogen, and hydrogen will share its electron with carbon, and we'll repeat that for the other 3 spots. And if I extend my ellipses here, you will see that from carbon's perspective, it has a total of 8 electrons and is pleased, and each hydrogen has 2 electrons, and each hydrogen is pleased. The end result is a stable molecule that we would draw in the following way. Once again, this straight line represents a covalent bond. And that covalent bond is 1 pair of shared electrons. And carbon is stable. Because all of its valence openings are filled, and each hydrogen is stable because all of its valence openings are filled. So that's it for covalent bonds. Part 2 will be hydrogen bonding, and you can click that one once it's up.